Hello everybody and welcome back. We're looking at question 8 now on the 2004 Euclid, and the first thing you might notice is that both parts for 8 are written, and this is going to continue on for the rest of the contest. 9 is written, 10 is written. We're going to get into those in later videos, but right now we're just concentrating on 8, specifically 8a. If t is equal to x squared plus 1 over x squared, determine the values of b and c so that x to the 6 plus 1 over x to the 6 is equal to t cubed plus bt plus c for all non-zero real numbers x. Okay. So it looks like we sort of have a function in x over here, and if we plug in our t's, we'll have a function in x over here as well. Then I think it's just up to us to sort of match the coefficients. Yeah, it doesn't seem to be anything too tricky in the a part there. That's okay. So we're told that t is x squared plus 1 over x squared. And I would say something like sub in t. So x to the 6 plus 1 over x to the 6. Now we want that to be t cubed. But what's t? It's x squared plus 1 over x squared. Then we got bt. X squared plus 1 over x squared. So b, x squared plus 1 over x squared. And then plus c, right? Yeah, just a plus c all by his lonesome there. So I would expand this out. You got to be careful expanding out your cube. But you get x to the 6 plus 3. You get an x squared squared, so x to the 4. And then a 1 over x squared. 3, you'll get an x squared, and then you'll get a 1 over x squared squared, so that'll put an x to the 4 on the bottom. And then 1 over x to the 6. And then the rest of it's fairly straightforward to expand out. And then still that c by his lonesome. I am going to cancel out these values right here. And I guess we could also cancel some of this out. So then what we've got? We've got something that should be 0 everywhere, or I guess for all the non-zero x's. But what have we got? We got 3x squared. I'll pair it up with the bx squared. Plus 3 1 over x squared. I'll pair that up with the b 1 over x squared. Plus c. So that's really 3 plus b x squared. I'll put the c in the middle so that my powers are decreasing. And then 3 plus b again, 1 over x squared. Alright. For this to be 0 everywhere, and this is true for really any sort of polynomial expression, or even polynomial-looking expression, this is that if you want it to be 0 everywhere, the coefficients must be 0. So that means the 3 plus b has got to be equal to 0. C has got to be equal to 0. And another 3 plus b is equal to 0. So we can see b is equal to negative 3, c is equal to 0. I might put a little box around this, but that's it. We've got our reasoning. There really wasn't a whole lot to write here. It was more just, plug in what t is and equate the coefficients. We did have to mention, why do the coefficients have to be 0, but that's just a small little thing. So we wrote everything, sure, but there really wasn't that much to 8a. Let's see if we can't get a little bit more of a challenge with 8b here. Alright. If x is a real number, satisfying x cubed plus 1 over x cubed, so very similar to the sort of expressions we were seeing in a part. So if that's equal to 2 root 5, that's weird, determine the exact value of x squared plus 1 over x squared. Interesting. Very interesting. Huh. Well, it puts me in mind of all these expressions sort of remind me of something. I'm going to say I'm going to say let t be, well, they use t. Let's use some other letter. What's a good, I don't know. What comes after t? U. Let u be x plus 1 over x. Now this is a very interesting little fella here. Because, for example, u squared is going to be x squared plus 2x 1 over x plus 1 over x squared. And it's going to be x squared plus, well, these guys are going to cancel out. We're going to get 2. So u squared minus 2 is the value we want to calculate. Okay. So u squared minus 2 is x squared plus 1 over x. Okay. So that's something interesting to note, that if you raise it to an even power, you'll get some integers in there. And if you raise this guy to an odd power, I think, let's see, x plus 1, we'll go slowly, besides we should be showing our work anyway. You'll get x cubed, 3x squared, 1 over x. So things don't quite cancel out here, but I think they cancel out in an interesting way. X cubed plus 3x plus 3, 1 over x, plus 1 over x cubed. And this is x cubed plus 1 over x cubed, which is a value they gave us, plus 3, and look at that, we get u sitting in here. So this is 2 root 5 plus 3u, which frankly is a weird expression, but that's okay. And yes, it is 2 root 5. All right. What to do? Oh, okay. So I think u cubed minus 3u is 2 root 5. And if I divide by u, I'll get u squared minus 3 is 2 root 5. I was hoping, this is so close to the thing I want, but to get there I'd need to divide by u, and I don't know what u is. Is there anything I can do here? I really thought I was onto something with this u character. Now I'm not so sure. Let's take a step back here and say, okay, what have we got? So x is satisfying this, fine. Well, I'll tell you what, let's try something a little different. So let's actually ignore this. I know x cubed plus 1 over x cubed is 2 root 5. If I multiplied through by x cubed, I would get x to the 6 plus 1, which is 2 root 5 x cubed. And, oh, okay. Bring this over to the other side. Suddenly, we've got a quadratic in terms of y equal x cubed. Then we're looking at y squared minus 2 root 5 y plus 1 equals 0. We could get a value for y. We could. How would that help us? So y would be negative b plus or minus the square root of b squared, so that'd be 20 minus 4ac. Ooh, I like that because that's going to be 16, all over 2a. So this will be root 5 plus or minus 4, but 4 divided by 2 is 2. So that's y, that's x cubed. So x would have to be the cube root of one of these. Now it actually doesn't matter because they're going to be reciprocals of one another. So I was worried there for a second, because if we take a look, we could get a couple different values for x. But, you know, you plug x in here, you'll get something, and then it's reciprocal. But if you plug the other x in there, you'll get the reciprocal plus the original something. If you catch my meaning. It's like we could get 2 or 1/2 out, but if I plug 2 or 1/2 in here because it's symmetric, I still get the same thing out. I'm liking this a little better because I actually have x's I can deal with now. Now, do I want to rearrange this equation, or do I just want to go for it? So we want this, and it'll be some value, I don't know, v. And we get x to the 4 minus vx squared plus 1 is equal to this. Yeah, it's not really going to do anything for me. So I'll say, so x is the cubed root of root 5 plus or minus 2. So these x values are... Could I relate this in any way to the work I already did? No, I don't think so. Although the 2 and the root 5, I wonder if there's a relationship there. Anyway, these values are reciprocals. Should I justify that? Questions to think about. So they're reciprocals since the two values of y are reciprocals. So the cube root of 1 over y is the same as 1 over the cube root of y. And we know that they are reciprocals since, well, there's lots of reasons, but let's say since, we can just, well, heck, we'll just compute it. We could have been fancy and said since the constant term is 1, but I feel that that's not entirely the easiest thing to explain right now. Alright, so we get those ones. So fine. The x values are reciprocals. So let's pick one value of x to use. Maybe x is the cubed root of root 5 plus 2. I don't like this number. I am not happy with this number. Because it's a cube root outside an already sort of awkward number. I have to feel there's a better, like a slick way of doing this. I'm going to play around with it for a second. So let's say x plus 1 over x is, I don't know, some value d. X squared minus dx plus 1 is equal to 0. Okay. So then if then x squared, if I did x to the n, if that's equal to some other value e, then we'd have x to the 2n minus ex to the n plus 1 is equal to 0. I don't, not seeing anything good here. Because what I don't want to do, because they asked for the exact value. So I can't just take this number, plug it into my calculator, I need to actually show why x squared plus 1 over x squared is what it actually is. So, this one has me a bit stumped. It makes me think that 9 and 10 are going to be really, really hard. I have to believe that there's something I can do with this earlier observation. U squared minus 2 is this sum. D cubed minus 3d is the other sum. And does it relate maybe back to A part? Oh, you know what? It does. Oh, geez. Alright. Beginning anew. Everything's brand new. Okay. Let u be x plus 1 over x. I should have thought of this earlier, related back to A. They didn't have us do something in A for nothing, I don't think. Alright, so u squared is x squared plus 1 over x plus 2. So u squared minus 2 is x squared plus 1 over x squared. And then we made the observation u cubed minus 3u was equal to 2 root 5. Had I just put a t in there, we might have been a little. This might have been a little easier. In fact, let's put a t here anyway. No, not a t. No, I think I still want a u. Okay, I had this. I had this a second ago. What is this? So if t is something squared. Okay. Once again, beginning anew. Where's my eraser? Clear the page. Alright, let y be the square root of x. X is positive since x cubed plus 1 over x cubed is positive. If x were negative, this wouldn't be so. Okay. Let t be y cubed plus 1 over y cubed. We saw in part A that y to the 6th plus 1 over y to the 6th is t cubed minus 3t. But then that's x to the 3 over plus 1 over x to the 3 is, then this is x plus 1 over x. I thought, blasted, I thought I had it. I really thought I had it there. It's going to backfire. It's just going to end up being that u cubed minus 3u thing we already saw. Maybe I'm not using part A right. Maybe I'm not supposed to use part A at all. Mental note, if you are this stuck on a problem, by all means, move on to another one. But this is what I do, so okay. Maybe just let t be the thing I'm trying to solve for. Okay. Then we saw in part A, x to the 6th plus 1 over x to the 6th is t cubed minus 3t. No 0 here. Okay. Now, let's notice that two root 5 squared, which mind you is 20, is equal to x cubed plus 1 over x cubed squared. And then that becomes x to the 6th. Okay, I think we're using it right now. And then those will cancel out. Yeah, I think this is the proper setup, because why would they ask us in A to do something with 6's, and then in B use cubes and squares? I think we gotta write it this way and then square the cube thing. And that would also explain why there's a square root 5 there. It's almost been screaming at me the whole time. So this is to the 6 plus 1 over x to the 6 plus 2. These cancel. And this is t cubed minus 3t plus 2. So 20 is t cubed minus 3t plus 2. T cubed minus 3t, we'll bring the 20 over to the other side, minus 18 is equal to 0. I don't know if that helped me. Yeah, I think that might be one step too far. Maybe t cubed minus 3t, because if I bring the 2 over, we get 18 here. That 3, and I think if we take out the t, we get t squared minus 3 is equal to 18. And so t being equal to 3 solves this. All right? Because 3 and then 9 minus 3, that's... Okay, so that's true. Is that the only solution to this? I think based on the wording of the problem, it's got to be. I'm just trying to think if there's some way to show that. Well, it looks like the thing we want is 3. But how can I know that there's no other solution to this? So that's something I'm currently stuck on. Oh, what to do, what to do, what to do. That's what I'm working on. Is it the only solution I can deal with? As I recall, if I can do something like t cubed minus 3t minus 18, I think there's... Could I rearrange to get t? I think there's some way, something that says that sort of only has one solution, but let's instead say 3t is t cubed minus 18. Oh, okay, hold on. T cubed is 3t plus 18, and if we graph them, so the cubed looks like this, and the 3t plus 18 looks like this, and I think we would need calculus to actually say that there is only one intersection, so that's a little bogus. Yeah, we would need calculus to say that they don't intersect in more than one place, and they may actually. So back to the old drawing board. If you're satisfied with t equals 3 as the solution, by all means go to the next video, but it's a cubic, so in principle there should be 3 solutions. I'm trying to rule out them. I'm trying to say that it's one of the ones that only crosses the x-axis once or something like that. I'm just getting hung up on that part, and I'm not entirely sure what to be doing. So if t were negative, to make 18, which is positive, we would need t squared minus 3 to be negative. So we would need t squared to be less than 3. So in absolute value, t would have to be less than square root of 3. But then t squared minus 3 in absolute value would be less than 3 root 3, which is far less than 18. So we can't have negative solutions. Now how about positive solutions? For positive t, what's the equation? We got t squared minus 3 is equal to 18. Oh, well, if we know there's got to be a positive solution, now I think we can use the graph. So can only be positive solutions. Graphing, we see it goes through 18, so we got 3t plus 18, and then t cubed. Only one solution in the first quadrant, and I'm satisfied with that. And they're only going to cross each other once, because then t cubed grows too far. So t equals 3 is the only solution. You probably didn't need to write that to get full marks. You just probably need to get t equals 3. Thus, what was the original expression? X cubed plus 1 over x cubed, or x squared plus 1 over x squared is equal to 3. Wow, that took a lot out of me there. We're definitely bouncing back and forth on that one, but 8 is done. I shudder to think about 9 and 10, but we're going to take a look at them in the next video. And if you made it this long, thank you for joining me. I'll see you for 9 and 10 in the next video. Not going to draw this ending out.